Hello Honors Math 3. Let's review a chapter here on some limits and derivatives. Make sure you've tried these problems first before I give you the quick run-through solutions. Alrighty, if you're asked to evaluate a limit, that just means as your inputs into this function approach -2, what do the outputs of that function approach? Nothing strange happens on that function at x equals -2, so I can just plug in what is -2 cubed plus 1 squared. That's -8 plus 1 squared. -7 squared is 49, and the function values approach 49. Nothing strange for that function. Alrighty, if I ask you what do the function values approach when my x values approach 1, well, this is kind of strange, because if I plug 1 into that denominator, I get 0. You can confirm. And then this whole fraction is undefined when x is equal to 1. Okay, don't worry. We can do a little work here. And what is the limit as x approaches 1? Let's try to get rid of that problem spot. I'm going to pause and start to factor. Numerator is a difference of cubes, my SOAP pattern. One of these minus one of those. Square the first. Multiply them together and change the sign, square the last. And the bottom, the denominator, is factoring by grouping. Factor out an x squared, factor out of a 3, and now I'm going to factor that common term out of the denominator. Let me pause again. When I factor that x minus 1 out, I remove that problem spot, and actually now my denominator is defined as x approaches 1. That's 1 plus 3, which is 4. Numerator is 1 plus 1 plus 1, which is 3, and that limit, the function value, approaches 3/4 as x approaches 1. Undefined at 1, but the function values are approaching 3/4. Use left and right limits to determine if this function is continuous at x equals -1. Remember, for a function to be continuous, we need f of -1 to be the same as the limit as x approaches -1 of that function. First of all, I'm going to find f of -1. When I plug in -1, my output is 1. Then I'm going to find the limit as x approaches -1 from the left of that function, and I'm going to find the limit as x approaches -1 from the right of that function. When I approach -1 from the left, I plug into that first piece, which is -1 plus 2, which is 1, so far so good. Now I'm going to approach -1 from the right. I'm going to use that last piece. If I plug in -1 into the denominator, it's undefined, so I'm going to factor and clear up that problem spot at x equals -1. X plus 1, x minus 1 in the denominator. Get rid of that point of discontinuity. Plug in -1, that would be -1 in the top, -1 minus 1, which is -2, which is 1/2, and because these are not the same, this limit does not exist. Since the function value is not equal to the limit, so f is not continuous, or it is discontinuous, not continuous at x equals -1. Alright, but there's a little bit of testing there to be done. Alrighty, find the slope of the tangent line to the graph. What is a slope of a tangent line? That is a derivative. How do I find the derivative, the slope of the tangent line of that function at x equals 3? I can use that shortcut if you don't mind, because I can find a formula for the derivative. F prime of x is equal to multiply exponent times coefficient, knock down that degree by 1. Multiply exponent times coefficient, knock down that degree by 1. There's my formula for the derivative. So f prime of 3 is 3 times 3 squared minus 2 times 3, which is 27 minus 6, or 21. The slope of the tangent line at x equals 3 is equal to 21. You can kind of see it on a graph if you like. Evaluate a trig function. This is one of those we memorized. This is the one we need to be familiar with. What's the limit as x approaches 0 of sine of x over x, remember that one, is always equal to 1. This is a case where I force these things to be the same. Actually, let me multiply. I multiply by some creative factor to get this to be a 5x and that to be a 5x. Let's get rid of that 3 by multiplying by 5/3 on the bottom. That means I have to multiply by 5/3 in the top. This becomes the limit as x approaches 0 of, that's nothing special, 5/3 sine of 5x. But those 3's go away, and I'm left with a 5x in the denominator. So this limit is equal to 1. What is the limit as x approaches 0 of 5/3 times this limit, maybe I should write it, limit as x approaches 0 of 5x over, oops, I'm sorry, I'm rushing, sine of 5x over 5x. This is 1. This is approaching that constant function of 5/3, and that limit is simply 5/3. Nice. Where is this function continuous? Well, a rational function we expect to have some problem spots. So I'm going to say that this function is continuous everywhere for x not equal to, where's our problem spots? Can you start to factor that function or look at your factors? I'm going to group it and factor it. When I grouped and took out that x minus 3, notice I can factor that numerator again, so I'm going to pause and do that. Notice after I take out that x, I'm left with an x plus 2. Once I have a common factor, I have a whole at x equals -2 on that graph. What I'm left with is a vertical asymptote at x equals 4. This function is continuous everywhere. Everything's fine except at -2 and 4. Alrighty. What's this limit? What are my function values approaching as my x values approach pi over 4? If I plug in pi over 4, will I get a 0 in the denominator? Nope. So I can just plug in pi over 4. Really, I'm going to approach the function value of what is tangent of pi over 4 over 1 plus cosine of pi over 4 squared. What is that going to equal? Let me pause with a unit circle. This is defined but messy. Tangent of pi over 4 is 1 over 1 plus cosine of pi over 4 is root 2 over 2. I have to square that. Denominator becomes 1 over square the numerator and denominator. I get 2/4, which is 1 over 1 plus 1/2, which is 1 over 3/2, which is 1 times the reciprocal of the denominator, and I'm approaching 2/3. Good one. Alright, start to sketch this thing with any holes, vertical asymptotes, horizontal asymptotes. Of course, I'm going to factor this thing and see what happens. Notice with a common factor I can reduce. I get a whole at x equals 0. I'll actually find that ordered pair. I get a vertical asymptote at x equals -3. Where was my horizontal asymptote? Horizontal asymptote is the ratio of the leading coefficients, which is at 2. Let me pause. Specifically, when x equals 0, I can take out that x. When I plug in x equals 0, I'm left with this, which is -2/3, and I place that whole. Feel free to spend some more time on this one. If you find the limit as x approaches -3 from the left, using this function, I got a negative over a negative, which is approaching positive infinity. So this piece must be up here. When I find the limit as x approaches -3 from the right of that fraction, I was left with negative over a positive, which is approaching negative infinity, which confirms that this graph looks something like this. Alrighty, so you can take your time on that with those limits if you like. Now to think about those a little bit more. When I see this, I kind of see these properties that we knew, so I'm going to separate this. I can separate that fraction into a sum of two fractions, so I can separate that into a sum of two limits. Now I want to get rid of that 7 to make sure those match. This is where I use that trick of multiplying by 1/7. Multiply by 1/7. And I am left with, let me pause for the sake of time. You'll start to recognize this. Multiply top and bottom by 1/7. Okay, gives me that numerator, cleaner denominator. This is simply equal to 1, that limit. This limit is memorized as equal to 1, so I'm left with 1/7 plus 1/7, and the value of this limit is 2/7. Alrighty. Take out your graphing calculator if you have not, and find the derivative of this function at x equals pi over 3. So we need f prime of pi over 3. It's going to be approximate. That's going to be messy. How did we plug that into our calculator? Remember, that was math 8 numeric derivative. All right, I'll jot down what it should look like. Your calculator should always be in radian mode so that when we graph trig functions, you're really just plugging in numbers. Plug that into your calculator and it gives you approximately 0.057. So the slope of the tangent line at pi over 3 is about 0.057. Okay, let's write a function v of x for the volume of this box and find the average rate of change. If you remember, average rate of change is simply a slope for the volume from x equals 2 to x equals 4 feet. That is change in y over change in x. V of 4 minus v of 2 over 4 minus 2. Here's the formula for the volume, length times width times height. Check if you would while I multiply that out. When I plug 4 into that function, I get 160, minus when I plug 2 into that function, I get 24, divided by 4 minus 2, which is 2, whatever that is, and I get an average rate of change of 68. Volume is cubic feet per foot change in the radius. Not radius, per foot change in dimension. Okay, find the instantaneous rate of change from that volume with respect to x at x equals 5 feet. What is an instantaneous rate of change? That's the slope of the tangent line. What's the slope of the tangent line? That is a derivative. So really, I just want v prime of 5. If my volume, let me pause, formula for the volume, formula for the derivative, 6x squared plus 4x, using the shortcut, v prime of 5 is 6 times 5 squared plus 4 times 5, and let me see what that is. I get 170 feet cubed per foot, so that kind of makes sense. It's changing faster as the length, the change in dimension gets bigger. That makes sense. Alrighty, use your graphing calculator to sketch a graph of this function. Make sure you're in radian mode, and then find the derivative at x equals -2. If you had trouble graphing that because there's no secant button in your calculator, remember secant is the reciprocal of what? The secant is the reciprocal of cosine. So actually I can plug this into my graphing calculator. Plug that in y1, and I get a pretty cool graph that looks like this. To find a derivative, I have to use that math 8 because this is a more complicated function, and find that derivative. What do I want? F prime of -2. Find that. When I plug that into my calculator, I got 8.098, depending what we round to, 8.10 is f prime of -2. Alrighty, grand finale. Let's find a function for the derivative. That's f prime of x, but using the difference quotient. What was the difference quotient? That's the limit as h approaches 0 of f of x plus h minus f of x all over h. Pause and plug x plus h into that function and then subtract the function itself. Here I plug in x plus h and plug in my original function to subtract it. Here I square and start to distribute. I'm going to distribute one more time. Simplify, divide out that h. This term is gone. There's a formula for the derivative that